everyone, welcome to 6th class of time and distance. My name is Ravi Prakash. So we'll discuss again this concept we're discussing, that when two parameters are inversely proportional with each other, if one is in AP, the other has to be in HP, harmonic progression. Okay, and this is again a very good example of it, right? This question, very good example of this question, that concept. Okay, now I would like to again solve this question by that method only. Okay, so see here. ABC starts from same place and traveling in speeds of 80, 96 and 120 km per hour. Correct. B starts 2 hours after A. If B and C overtake A at the same instance, how many hours after A did C start? So right now I can't figure out anything other than HP or AP or not, right? Not necessarily in every question speeds will be in HP or AP, right? But when we have this kind of questions where 3 or 4 speeds are given, right? We should first check either this series is in AP or HP or not. AP or HP or not. Not any other fundamental solve, right? That we'll see later. Okay. But if they are in HP or AP or HP, my work will be very easier, right? So I need to check these are in HP or AP. Obviously this series is not in AP because common difference is not same. 80 to 96 difference is 16. 96 to 120 difference is what? Not 16. It is 24. So in AP, common difference, right? That is difference in any two consecutive terms, right? Difference between any two consecutive terms are same. Here it is not same. 16 and 24 not same, right? That means it is not in AP. Come to HP. Take it in HP or not, right? So let's say 80, 96 and 120 are in HP. It's like A, B and C are in HP. Then B is equal to 2AC by A plus C. Then here 96 should be equal to 2 into 80 into 120 by 80 plus 120. So it is equal or not? So 160 into 120 by 200. 0 cancel. 16 into 6. 96, right? That means 96 equal to 96. That means harmonic mean of these two numbers is 96. That means this series is in AP. Right, that's right. My question is solved very easily now. Okay, because when speeds are in HP, then time has to be in AP because distance is constant. Here. And talking about same distance, same place and travels since same distance, right? So distance is constant, so it is always true. Therefore, if time is in AP, so time interval between time of A, time of B, and time of C, right? So B starts 2 hours after A. So if time is in AP now, so gap of any two terms should be 2 hours only, right? That means gap in AP. What is in AP? That common difference is same, right? Common difference is same. Difference between any two consecutive terms is same, right? So it is 2 hours. So I know that now time is in AP. Time intervals are in AP, right? So if here a difference is 2 hours, here difference has to be also 2 hours. So it is gap between A and C. So how many hours A after A did C start, right? What is the answer? Answer should be how much? It should be 4 hours. 4 hours should be the answer for this beautiful question. Very nice question, right? Very nice question. If a person travels at speeds of 12 km per hour, 15 km per hour, he will reach office at 11 PM and 9 PM respectively. If he wants to reach the office at 10 PM, what speed should he travel? Now see. This is quite visible. This is clearly visible here. Time, intervals, and speed, right? So time is he reaches at 12 km per hour. Sorry, time is what? Time is 11 PM. Sorry. Time is 11 PM. Then his speed is 12 km per hour. Time is 9 PM. Then his speed is 15 km per hour. So when time is 10 PM, what is the speed? Right. So again same thing. See, 9, 10, 11. Time intervals are in AP. Speed has to be in HP because distance is constant. We're talking about some particular distance here, same distance here, right? For all these three people. So distance constant. If time is in AP, speeds has to be in HP. So let the speed here be b. Therefore, b is equal to 2ac by a plus c, that is equal to 2 into 12 into 15 by 12 plus 15, that is 24 into 15 by 27. 3 8 ja, 3 9 ja, 3 3 ja, 3 5 ja. So it becomes 40 by 3. What is 40 by 3? 13.33 kilometer per hour is the answer for this question. Right, so again a very good application of time, speed and distance. If a person travels at speeds of 20 km per hour and 60 km per hour, he will reach office at 6 p.m. and 2 p.m. respectively. Okay, find the distance. See, this question is a perfect example, right? Not to stick to a particular method. Okay, in last question, a similar question, we could solve it much easily since time intervals were in AP, so speeds has to be in HP. But I told you earlier, right, that it may not be applicable in every question, right? That is a particular method that when time is in AP, speeds in HP or vice versa. Only for AP and HP, but those times interval cannot be in AP, right? Then we should know how to solve the problem, right? It's a very good question with respect to that one. Okay. Now see here, if a person travels at a speed of 20 km per hour and 60 km per hour, he reaches office at 6 p.m. and 2 p.m. 6 p.m. and 2 p.m. respectively. Find distance, right? Very quickly, I'll take distance as the LCM of these speeds. Again, same thing. LCM of 20 and 60, that is 60. So distance is 60 km per hour. Okay. Time taken at this speed of 20 km per hour should be how much? 3 hours. For 60 km per hour, 60 by 3, 20, 60 by 23 hours at a speed of 60 km per hour. That should be 1 hour only. 60 by 60 is 1 hour, right? So if distance assumed is 60 kilometers, sorry, not this distance, not speed, sorry, 60 kilometer. If distance assumed is 60 kilometer, then we can what we need to compare here? We have 6 p.m. and 2 p.m. That means time difference I can compare, right? So time difference here is of 2 hours. Okay. So if distance assumed is 60 kilometer, time difference is of 2 hours. But how much time difference I want? I want time difference of 4 hours, right? So for time difference of 4 hours, what should be the distance? Double. 60 into 2. That is 120 kilometer. This is the answer for this question. 120 kilometer is the answer for this question. Right, very quickly. This LCM method is very good. We can do the questions very quickly. Okay. Now, similar question, but a good one than the last question, right? If a person travels at a speed of 40 km per hour and 60 km per hour, he will reach office at 7 p.m. and 2 p.m. respectively. If he wants to reach office at 5 p.m., at what speed should he travel? So you should quickly observe here that time are 257. Neither it is in AP nor it is in HP. So I can't apply that funda, right? So come back to normal method. Okay. Assume distance as LCM of these speeds, that is 40 and 60. So what is LCM of 40 and 60? 120 kilometer, right? Just read the table of 60 and see where does 40 come, right? 60 minus 60, 40 is not matching. 62 is 120 kilometer, 120 is a multiple of 40 also, right? That means 120 kilometer is the distance, assumed distance, right? This is the assumed distance. So assumed distance is 120 kilometer. Okay. Now, time taken at the speed of 40. Okay. So time taken at the speed of 40 km per hour and time taken at the speed of 60 km per hour is how much? So 120 by 40, 3 hours, and time taken at 60 km per hour is how much? Distance 120. So 120 by 60, 2 hours. Again we have here 7 p.m. and 2 p.m. So time difference is of 5 hours, right? That means actually it is here difference is 1 hour. Again say that if time difference is 1 hour when distance is 120 kilometer, but in my case I want time difference of how much? 5 hours. Okay, Actually, time difference of 5 hours. What is distance? 120 into 5. So distance is how much? It is 600 kilometer. Correct. Distance is 600 kilometer. Right. So see now, little bit pay attention here more, because this is like a good question with respect to previous questions. Okay, distance we got is 600 kilometer. Okay, so now I can get actual time. Okay, actual time. Okay, see here, actual time taken at 40 kilometer per hour. Time taken at the speed of 40 kilometer per hour is how much? 600 by 40. That is 15 hours. Right? Time taken at 60 kilometer per hour is how much? 600 by 60. That is 10 hours. Right? Now see here. He is reaching his office at the speed of 40 kilometer per hour. He is reaching at 7 p.m. Okay. The person is reaching his office at 7 p.m. Okay. At the speed of, take anyone. So at the speed of 40 kilometer per hour, he is reaching at 7 p.m. He is reaching his office at 7 p.m. Then when did he start? He started at, very quickly you should answer, right? When did he start? At 40 kilometer per hour, he is reaching 15 hours to reach the office, right? And he's reaching at 7 p.m. So when did he started at how much? 7 p.m. minus 15 hours. That is how much? 7 p.m. minus 12 hours. 7 a.m. minus 3 hours. 4 a.m. Right? So he started at 4 a.m. Right? So to reach office at 5 p.m. So he started at 4 a.m. Right? You can take either one. You can take 60 also, no issue. At 60, he is taking 10 hours. Right? And he reached at 2 p.m. So 2 p.m. minus 10 hours. Right? Again 4 a.m. only. So same thing, right? So question is same now. He started at its same time. So it should be some same time only, right? It can't be different time. So it started at 4 a.m. Right? Now second thing, to reach at 5 p.m. he will travel for 13 hours, right? He will travel for 13 hours. No, 4 a.m. to 5 p.m. same day. So 4 a.m. to 4 p.m. 12 hours plus 1 hour, 13 hours, right? So to reach at 5 p.m. he will travel for 13 hours, right? So at what speed should he travel? So distance is how much? 600 kilometer. His time is how much? 13 hours. So at what speed he should travel? He should travel at 600 by 13 kilometer per hour. This is the answer for this question. 600 by 13 kilometer per hour. Okay. Correct, right. Once again, you can understand this question. It's a very good question actually. You can understand this question. You can do it very fastly. Do it mentally. Okay. They assume distance as LCM of 40 and 60, that is 120 kilometer. So 120 kilometer at the speed of 40, it takes 3 hours. 120 kilometer at the speed of 60, it takes 2 hours. Difference is of 1 hour, because I know time difference in question how much. Actually, it is 5 hours. 2 p.m. to 7 p.m. 5 hours, right? So if I assume distance as 120 kilometer, time difference is 1 hour. That means if time difference is 5 hours, what is the actual distance? It is 600 kilometer is the actual distance. Okay. So he is traveling 600 kilometer at the speeds of 40 kilometer per hour. How much time he will take? 15 hours. Okay. He is traveling 600 kilometer at the speed of 60 kilometer per hour. How much time it will take? It will take 10 hours. Okay. Fine. So you take either one, right? Suppose I take this 10 hour. Okay. So he started from his office at 10 hours before, so that he reaches his office by 2 p.m. Right? At 60, he reaches at 2 p.m. Okay. So he must have started 10 hours before 2 p.m. So 2 p.m. minus 10 hours, how much? 4 a.m. Right? That is 4 a.m. here. 4 a.m. Or 7 p.m. minus 15 hours. Again 4 a.m. That means he starts from his home at 4 a.m. and let's say his office is at a distance of 600 kilometer. So it can't be office, right? It's illogical actually. So take it for another city, right? So he start from his hometown, from his city at 4 a.m. and his hometown is at 600 kilometer. Okay, how much time he need to travel? He need to reach his office at 5 p.m. Right, make it office. Okay, so for office it is 5 p.m. or hometown. So he has to travel for 13 hours, right? 13 hours. 4 a.m. to 5 p.m. 13 hours, right? Distance of 600 kilometer to be covered in 13 hours. What is the speed? 600 by 13 kilometer per hour should be the speed. This is the answer. This is the answer. Okay. I hope you got it. This is a very nice question. Okay. Next question we'll see. Now, a quite easy question it is. Okay. Compared to previous question, it is easy. I'm just doing all the variety, right? I'm putting all the variety you'll find in any book or any website, right? All the good varieties with the best of methods. I've compiled it. Many questions have been framed by me. Many questions have been taken from the previous year examinations, right? So all the varieties we have discussing here. Okay, a man takes 5 hours 45 minutes in walking to a certain place and riding back. Okay, no, quite logical. See here. From A to B he is going. A to B. Okay, he takes 5 hours 45 minutes in walking to a certain place and riding back. So he's going by walk. Okay, that means he is going by walk and is coming by ride. That means take suppose example bike. Okay, so he's coming by bike. So it takes him walking, right? You can assume like okay, walking plus riding takes him 5 hours 45 minutes. Okay, he would have gained 2 hours. He would have gained 2 hours by riding bike both ways. Okay, that means if from A to B he would have walked only, again rided both sides, A to B, right? He would have rided both sides now. So rided from A to B and again B to A, again rided from B to A. So if he rided from both sides, so he gained 2 hours. That means he is now taking how much time? 3 hours 45 minutes, right? Gaining 2 hours means he took time of 3 hours 45 minutes. The simple funda here is if one side walk is replaced by ride, he is gaining 2 hours. Okay, or I can now from here to here you can see if one side is replaced by ride to walk means he is not riding, he is opting to walk, so he will take 2 hours extra. He will take 2 hours extra. Okay, that means if ride is replaced by walk, okay, he is taking 2 hours extra. If one ride, I should write one ride because one ride means one side. Ride is replaced by one walk, one side walk. It will take 2 hours extra, right? So, the question: how much time it would have taken to walk both ways? To walk both ways, right? That means from A to B now, he is walking, right? He is walking at A to B. He is walking, and B to A. He is also coming by walking. So again, see the scenario from here to here, from here to here. I told you right. One side ride is replaced by one walk. 2 hours extra time is taken. Okay. So another from here to here, from here to here, another one side ride is replaced by one side walk. Another 2 hour extra time it will take. So here what is the time taken? 5 hours 45 minutes. So here 2 hours extra. 5 hours 45 plus 2 hours extra, right? That is how much that is? 7 hours 45 minutes. That is the answer. So you can mentally do it, right? You can simply think that okay, one side by walking, one side by riding, 5 hours 45 minutes. If I ride both sides, it is saving 2 hours time. That means if one side walk is replaced, if one side ride is replaced by one side walk, it will take 2 hours extra. Or one side walk is replaced by one side ride, it will save 2 hours time. So from here to here, he is again replacing one side ride by one side walk. So again he should take 2 hours extra. So here in this situation he was taking 5 hours 45 minutes. Now he should take 2 hours extra. So 7 hours and 45 minutes. That is the answer for this question. Okay. Okay, next question. Okay, a very interesting question it is. See, A train approaches a tunnel AB. Inside a tunnel, a cat located at a point that is 3/8 of the distance measured from the entrance A. Okay. When the train whistles, the cat runs. Okay. If the cat moves to the entrance of the tunnel A, the train catches the cat exactly at the entrance. Okay. If the cat moves to the exit B, the train catches the cat exactly at the exit. What is the ratio of the speed of the train to the speed of cat? Okay. That's a good question. Just understand the situation here. See, the tunnel here. Okay. Assume a tunnel AB. Assume a tunnel AB. A train is approaching this tunnel. Let's say train right now is at a distance of x units. This distance is x units. Okay. Distance is x. And cat is sitting 3/8 of the distance measured from entrance A. That means cat is here at this point, and this is 3/8 of meter. That means it is how much? It is 5/8. So what is the ratio of this side? 3:5. That means this side is taken to be 3 units. This side to be taken as 5 units. If length is supposed to be 8 units. Okay. So 3:5. So I can rightly write that this side is, this is 3 units. Okay. This is 3 units and this is 5 units. And total length is supposed to be how much? It is 8 units. So see, now when train whistles now, right? Now, see, this is a situation here. When train whistles, if cat runs towards entrance A, it will meet the train at A. That means the time in which the cat runs 3 units, train also runs x unit. Okay. So when cat runs 3 units, train runs x. Understand this point. When cat runs 3 units, train runs x. Okay. Now, for exit side, if I take, so if cat is meeting the tunnel at train at point B, right? If cat runs towards point B, again it will exactly meet, right? And then the cat and train will be at the same position. Okay. Cat and train will be at the same position, right? So when cat and train is at same position when cat runs towards the exit. Okay. That means for coming to exit, right? So capacity of cat is this much only. Cat can run 3 units when train runs x unit. So when on either side, right? So when train runs x, so let's say this side also cat will be able to run 3 only. Get that much time. So cat has run 3 now. So now train has come here. Train has come here. Okay. Cat has run 3 units. See, when train runs x unit, cat runs 3 units. So cat is running 3 units, right? Not only on entrance side, no. It is like when train is running x unit, in the same time, cat can run 3 units on either side, right? If suppose the time is t minutes, so in t minutes, train comes from here to here. So in t minutes, cat can travel 3 meter. Okay, in t minutes, cat can travel 3 meter. So 3 meter, it could be this side or this side. No issue, right? Cat can travel 3 meter. Suppose I'm taking another one. Okay, that if train travels x, okay, so in the same time, cat will travel 3 meters. So cat will come at this point now. Cat will again come at this point now. So now distance left is how much? So distance left is further 2 only now. Okay. So now train is at this point. Cat is at this point. Okay. Cat is 2 units away from B and train is 8 units away from B. Okay. So both are reaching B at the same time. That means in the time when cat runs 2 units, train runs 8 units. Same time, right? In same time, cat runs 2 units and train runs 8 units, right? Therefore, distance of cat to distance of train. What is the ratio? 1:4. Distance of cat to distance of train. Distance to cat. Cat traveled 2 units. Train traveled 8 units, right? Distance of cat to distance of train. What is the ratio? 1:4. Therefore, now since time is same, right? So again get to formula. Distance is equal to speed into time. time is same, that means time is constant. That means distance is equal to k into s. That means distance is directly proportional to s. That means d1 by d2 is equal to s1 by s2. That means ratio of distance equal to ratio of speed. So if time is same, ratio of distance is equal to ratio of speed. Always true. If time is same, ratio of distance is equal to ratio of speed, right? Therefore, speed of cat to speed of train. What is the ratio? 1:4. That is the answer. That is the answer. Clear? Right. So again, just visualize this problem. This is a tunnel. A train is at a distance of x units from tunnel. Right? Cat is somewhere in the middle of tunnel. When cat hears the whistle of the train, okay, it runs toward the exit. That means both will run for same time and both will meet at exactly exit. If cat runs in the opposite side, right, that means both will meet at the exit. And if cat runs on the same side, both will meet at the entrance, right? This is a question here. So I'm saying that in the time when train runs x units, that means the train comes exactly at the entry point of the tunnel. Okay. So let's say that time is t seconds. When train whistles and cat start turning, after t seconds, train comes at the entrance by covering x unit. So in the t second, cat can also, let's say, cover 3 units or 3 meters. Okay. That's why cat is meeting the train at the entrance. That means capacity of cat is this much only when compared to train. When train runs x unit, in the same time cat can run 3 units. So if I take this in the opposite side, so if train runs x units, cat will run 3 units. So cat is right now 5 units away from B. Okay. So when train runs x, cat runs 3. So now train is at the entrance and cat after running 3. So 5 minus 3, 2. So cat is 2 units away from B. And both have to meet at the exit at the same time. That means in the time when cat runs 2, the train runs 8 and both meet at the exit. That means ratio of distance is what? 2:8, that is 1:4. Okay. And since time is same, so if time is same, ratio of distance equal to ratio of speeds. Okay. That means if the ratio of distance is 1:4, then ratio of speed is also 1:4. Okay. This is the answer for this question. Very nice question. It's a previous year CAT question. Okay. Okay. Thank you. We'll cover in next video now.